Now let's look at how we can use fractions, or when we need to use fractions solving an algebraic statement. So we have some equation, x plus 1/4 over x equals 7. And I want to evaluate it at the value 6 and 2/5. Step one, not a fan of mixed numbers. Let's convert that to an improper fraction. So that becomes 32 over 5. 6 times 5 plus 2 all over 5. Now we have a fraction. It's easier to use improper fractions than mixed numbers when we're solving equations. X, in this particular case, let's kind of have some coloration for you. So 32 over 5 plus 1/4 times 32/5 equals a 7. So I simply inserted my value of x everywhere there was that value of x. From here, we need to add or solve the equation. Remember, we have to go through our order of operations or a developing order of operations, which means I need to multiply first before I do anything else. So I have 32/5. 1/4 times 32/5. Multiplication with fractions, just multiply across. 1 times 32 gives me a 32. 4 times 5 gives me a 20, equals a 7. From there, we need to find a common fraction or a common denominator. It looks like 20 will be my common expression or my common value for my denominator. So I can need to convert 32/5 to something over 20. I don't know what that is right now. So 32 over 5. Need to multiply it by a 4. 32 times 4 is 128. So I have 128 over 20 plus 32 over 20. And I'm asking, does that equal 7? 128 plus 32 gives me 100 and what is that? 28 plus 32, 160. All over 20, is that correct? 160 divided by 20, does that equal 7? 160 divided by 20 is equal to 8. So 8 does not equal to 7. So that tells me evaluating this expression for that value was the wrong x, was the wrong value. So that one does not equal out. Let's look at 1/7 minus w equals 1/2 w. Evaluated that at w such that it equals 2 over 21. We insert that value everywhere we see a w. 'Once I'm able to insert it everywhere, it's a process of evaluating it. Again, what we're looking at is, did we choose the right value for this to be a true statement? Or we're just evaluating if that produces a true statement. So I see I have an addition or a subtraction problem, they're the same, and a multiplication problem going on. On the right side, multiplying is just multiplying top times top, bottom times bottom. So 1/2 times 2 over 21 produces a 1 times a 2 over a 2 times a 21. And I wrote it that way because I saw that there were some factors that could cancel out. The 2's factor out. And so on the right side, I'm just left with a 1 over 21. On the right side, 1/7, what's the equivalent expression of 1/7? Can we do that? Did you come up with? What do you think it is? 3 over 21 minus 2 over 21, and that produces 1 over 21. And that value did produce a solution, or did produce an equation that was true. So this W works if W is 2 over 21. Are you guys all right with how that came from? Want me to show you? 1 over 7 I knew 21 was my common denominator. So what's my clever version of 1? Has to be a 3 over a 3. 7 times 3, 1 times 3, boom.